Good afternoon, everyone. Thank you for joining this online demo. My name is Jean-Claude Borel, and today, during the next 16 minutes, we will discuss different modeling aspects of a large dam during construction and operation. During the whole session, your microphone will remain muted to avoid any background noise, but you have the possibility to raise questions via the question box of GoToWebinar. And from time to time, I will try to have a look. Otherwise, I will get back to you regarding your question after this live session. Having said that, let's take a look at what we are going to do today. Basically, this live demo is based on one of our tutorials that you can find on our website, which is construction and operation of a large dam. And in this tutorial, basically, we discuss several aspects that we are also going to discuss during this live demo. So the first thing, we will show how to import a CAD geometry to Diana. Today we will use a step file that I already have from a dam and its foundation. Then we will do some operation on the geometry to complete the geometry by including the definition of the cantilevers. So we will be splitting the dam into separate segments and also define the reservoir water level. Of course, we will assign material properties. We will define some constraint. We will assign loads in terms of dead weight and also the hydrostatic pressure of the reservoir. And finally, we will set up a phase analysis consisting on 3 phases. First, a phase where we only have the stress initialization of the foundation. In the second phase, we consider that the dam is built. And finally, in the last phase, we grout the interface between cantilevers and we operate the dam. So we will apply also the hydrostatic pressure. In terms of material, here are the material for the dam, the foundation, and the different interface between the dam foundation and also for the cantilever. The dam is assumed linear elastic. For the foundation, we consider a more Coulomb failure criterion. For the dam, we assume that the foundation is massless. We are not focusing on the mechanical response. We focus only on the mechanical response. For the interface between the dam and the foundation, we make use of a more Coulomb friction model and a gapping model for the interface opening. So it means that Diana assumes that a gap arises if the tensile traction normal to the interface exceeds 10 kilonewton per square meter. And finally, for the interfaces between the cantilevers, we need to define a material that will be used when the interfaces are not grouted in phase 2, and the material to be used when the interfaces are grouted, which is the last phase in phase 3. So, and in both cases, this material for the interface are linear elastic. So, having said that, let's move to Diana. Here is my Diana window, and we are going to start basically the modeling. So as usual, the first thing you need to do is, of course, to define a new project. So I'm going to call it dam construction. I've already created a folder for that, so I stick to my working folder. We are going to perform a structural analysis, which is on by default. The model is 3D. I'm going to increase the size to 10 kilometers to make sure that I can accommodate the whole entire model. So again, this is an important parameter because this basically defines the size of your modeling box. So you should make sure that it's big enough to accommodate your model. And for the measure type, we go for exact weight dominant and we keep the mesh order linear. We are all good. So Diana is going to set up the environment for us. In terms of unit, I'm going to use meter. For the mass, I go for ton, kilonewton for force, second for the time, and I go for Kelvin for temperature. and degree for the angle. So we are all good, and the first step of this demo will be to import a CAD file. So to do that, I go to File on top, then I click on Import CAD file. And then automatically it goes to my working directory that I have set up. And here you can see that I have a step file, which is my CAD model. And that's also the file that I want to import. So I select this file, and I click Open. So automatically, you see that in the geometry tree, I see some shapes appearing. So one is for the dam, and the other one is for the foundation. So this CAD model is relatively simple. It only consists in two shapes. So the first thing we can do to make it a little bit more realistic is first to rename the shape. So this one, I'm going to call it dam, and the other one, foundation, just to make our administration a little bit easier. I can also give it some more realistic color, so brown for the foundation and some light concrete color for the dam. So I can rotate the model so that you better see onto which it consists. So the two shapes are there. So what we need to do now is basically to divide our dam into segment or into cantilever segment, let's say. So to do that, we are going to use a set of vertical planes, which will be passing through the center of the circle, defining the curved surface of the dam. So having said that, we need to create some tool geometry in order to achieve this operation. So first, we are going to create this vertical plane by just extracting one of the face. So I set the geometry selection to face, and I'm going to select this one here. I right-click on the mouse, go to Modify, I call Extract. Automatically, you see that I have a sheet 1 which is created. So this is the extracted face of this resulting from this operation. Then I'm going to move this face to the middle of my dam, so up to somewhere here. So it's basically 380 meters along the x-axis. So to do that, I go to the move operation, I select the shape I want to move, and I define the offset, which is 380 in x, 0 and 0. And I click apply. You can already see a preview of it. I click apply, and now you see the shape or the plane is now right in the middle of the dam. Next, we are going to define the circle, which is following the curved edge of the upstream of the dam. So to do that, we are going to create a disk using 3 points over this curve. So I go there and I click on the circular sheet. I select the method, which is the 3 points, and I take the first point over there. The second point, I take it somewhere over there. And the last one over there. And I click create. So always keep in mind that until and unless you click create, it's only a preview mode, so nothing is created yet. Then I click create. I can close this, and you see that the circle appears over there. So what we need to do is basically to find the middle of this circle. And what we can now do is basically imprint the sheet, the vertical sheet, to this circle, and then we will be able to measure the diameter. So to do that, first I go to the imprint. For the target, I select the vertical sheet, and for the tool, I select the disk, and I click apply. And now I have my points that I can select. So first I'm going to measure the distance between these 2 points, and I see that it's 400 meters. So basically the radius is 200 meters, so I need to define basically the center over there. So to do that, I'm going to select one of the vertex, whether this one or this one. I'm going to select this one, and I'm going to move it 200 meter on the y direction, but on the negative side. So again, I change the filter to vertex. I select it, right click, modify, and click extract, and it results in the vertex one under my shape under the geometry tree. So now I'm going to move this vertex. So it's basically a similar operation to what I did with the vertical plane at the beginning. So I select the entity that I want to move, and basically I want to move it along the y-axis, but in the negative direction, so minus 200. And you see a preview that the point is going to place in the center. I click apply and then close. So now I have the center of my circle, and I will start basically defining the rotation for this plane. And by copying a certain number of times with different angle, I will create a set of vertical sheet that I will later intersect with my foundation. So we start first by rotating this plane by 5 degrees, and the pivot will be the center of this circle, of this disk. So I click rotate. I want to rotate this shape. The center is this point, and it's going to be 5 degrees. So here you have a preview. I click apply. And from now on, I'm going to repeat the operation with array copy. So I go to the array copy. I select this shape. The pivot is this point. And I start with 5 degrees on the z-axis, and I do that 4 times. You see a preview. I click apply. Now I select the last created sheet, which is the sheet 5. I keep the same pivot, but now the angle is 10 degrees, so the segments are getting a little bit wider, and I do that 2 times. And finally, I click apply, of course. Let me rotate this a little bit so that you can see better. Then I select the latest created sheet, which is this one. The pivot remains the same. Again, it's 5 degrees. And we go for 3 times this copy. And I click apply. So I have basically half of the section created. And using the mirror option, I'm going to get the rest, basically. So I go to the mirror, and I select all the sheets. So you can do it from the working window or also from the geometry tree. I mean, what you feel most comfortable with. And my pivot is in 0, 0, and the direction is X, and I click apply. So now I have my complete set of intersection plane, if I can call it like that. And now we are going to do a subtract operation between the dam and all this vertical sheet. So it will result in a dam segmented. So I go to the subtract operation over there. So the target is basically the dam. And the tool are basically all these sheets that have been created during this array copy. So I select all this, and I still need to select the first one, of course. And I don't need to keep the tool of simplify, and I click apply. And then you see that I have now my dam, which is divided into segments. So just in a few steps, as you could see, I mean, using a right combination of geometric operation, you can easily divide your dam into segments So of course you could also do that in your CAD model before to import it in Diana, but I mean, if you want to keep things a little bit simpler and do basically the advanced modeling operation in Diana, you can still do that. It's no problem. Now that I have my segment, the next thing is I'm going to imprint the dam into the foundation, because now the dam is defined into segment, and I also need the footprint of this segment into my foundation, because later I will define some interface, and I will need the target and source face to define my interface properly. So to do that, we go again to the imprint function, and the target is basically the foundation, and the tool are basically all the dam segment that I select here, and I still need to take the first one, and I go for imprint, and I click apply. So now if I pass the mouse under the foundation set, you can see in pink the highlighted results. So you see that the position of the imprint of the dam segment are now part of the foundation shape. And that's basically what we were looking for with this operation. In the next set of operation, I'm going to create a kind of plane parallel to the XY plane of the model, and bring it up to the level of the reservoir water level. And then in a second step, I will imprint this to the foundation, so that later I'm able to select this as the level of my reservoir. So I'm going to basically repeat what I have done at the beginning. So I'm going to extract a face, which will be basically the bottom of my model. So I put the filter to face. I select this bottom face. I right click. I go to modify, and I click extract. And then it results in a sheet 20, which is now a single face. And I'm going to move this face up to the level of the water level of the reservoir, basically, which is 410 meters in our case. So I go to the move operation, I select this sheet, and I define an offset, which is basically 0, 0, and 410 meters in the Z direction. If I rotate my model, you can see where this plane is coming, and I click apply. Again, I need to imprint this or to subtract this plane with the dam and the foundation. So first, to have the imprint of this plane into my foundation, so that later I can easily monitor the water level, but I also need that for the dam segment. So to do that, again, we go for the subtract operation. The target is basically the plane on this sheet that we just created. Sorry, not what I want to do. I do it again, this one. Select the sheet. And the tool, basically, it will be the foundation and all the dam segment. So I select all the dam segment. I need also this one as well as the foundation. So I can just quickly check that I have all my dam section and the foundation. And basically here, I want to keep the tool, and I click apply. So far you don't see much, but if I go to the foundation, it's okay. So now we continue, and you see that in my dam, for all the dam, I have the imprint, and I'm going to imprint now this into the foundation and the dam. So I click close, I go to the imprint. Oh no, sorry, I have already done that before, so I'm just mixing up the steps. So I have already the imprint of my dam into my soil foundation. because I could do that earlier or I could do that now. So, but I did it 2 steps before. So forget about what I just said. What I need to do now is to imprint this face, which is basically representing the water level of the reservoir on the upstream, into the foundation and also into the dam. So because now, with the previous operation, I have basically split this face, and now I can select it. So I go to the imprint. Sorry, I was mixing up 2 steps. I was already looking forward where I already did something. So I select my target, which is this plane. And for the tool, again, I'm going to select the foundation and all the dam segment. So I repeat my selection over there. I miss this one and the foundation. And then I can click apply. And now I can remove this one. I don't need this anymore. And you see that the edge is now imprinted into the foundation and also into the dam segment. I can also get rid of this one. My disk, which was there only for construction purpose, can be removed, and also this vertex, which was center of my disk, I can remove it. So if I rotate, you see better the position of the water level, I would say, like this. So it's imprinted on the foundation and also on every dam segment. So for the geometry definition, we are all good. So we started by importing a CAD file consisting in 2 shapes, a dam, which was 1 block, and a foundation. In a couple of operations, we managed to basically divide the dam into the segment. And we also made sure that we have the imprint of this dam segment as well as the water level imprinted into the foundation, but also into the dam segment. So it makes our life much easier for the coming step, where we are going to define the interface between the dam and the foundation, and also the water level. So we can now start with assigning some properties. So we go to the property assignment, and over there we are going to select basically starting with the dam and not with the foundation, which is already selected. So I select all the dam segment. I have all of them here. I'm going to select the structural solid element class, and I'm going to define a dam set material using the concrete and masonry class, and I go for linear elastic isotropic. No specific aspect to include, and over there I specify a Young's modulus, a pressure ratio. So 2.2 E7 for the Young's modulus, 0.2 for the Poisson ratio, and 2.35 for the mass density. We are all good. Again, I need to click apply because now nothing is assigned yet. So I click apply. And if I pass the mouse to the one of the dam segment, I can see that there is a material dam now which is assigned to this segment. And if I repeat the operation for all these segments, basically I can see that my material is assigned. I can also color the shape by material, and then it will also show you which material color is assigned to the different shape. Let's move on, and now we do the foundation. So I select the foundation. Again, I go for structural solid, and I'm going to define the material, which I call foundation, nothing very original. I'm going to select a class which is soil and rock, and I go for linear elastic isotropic with initial stress and shear pressure capacity as aspect to include, because we are going to make a stress initialization in our phase analysis. And over there, I specify basically the input value that were specified in my second slide, which in the material table. So you can also find this in the tutorial, which is online under our tutorial webpage. So I type the different value for the model. For the keynote, we are going to specify 0.65. And for the, we go for 40 degrees and 200 kilonewton per square meter. We are all good. And then we click apply. So again, I can check that the foundation carry a material which is named foundation. So assignment went fine. Now we are coming to, maybe, I don't know if we can say the difficult part, because it's not that difficult, but the one that needs a little bit of attention is the creation of the different interface. We are going to start with the dam foundation interface. And when you create interface, basically you need a source and a target. So you have to identify these two. That's the tricky part, I would say, but nothing that is how to say that really difficult when you have a proper administration. So in this case, we need first to select the faces on the foundation, which are basically the result of the imprint of the dam segment. So it will be the source. And then we will select the bottom face of the dam segment, which will be the target. So we are going to do that. And first I'm going to hide I want to keep the foundation. I want to hide the dam. It will make my selection much easier. So I add my different segments, and I will bring them back in the next stage. So now I can select my source. So first I go to the connection dialog box. I define a new set, which is a dam foundation interface with a typo, preferably. So it's an interface connection, it's closed, and I'm going to select the face. I rotate a little bit. And I can select in one go my all the source of which basically belong to the foundation shape. Now I'm going to hide the foundation and bring back the dam segment. Make sure that all your segments are on and you don't forget any of them. So it's there. I'm going to delete that because there was some already selection started. So I basically need to select the target, which are basically the bottom of every dam segment. You can rotate your dam to facilitate this in the meantime. This is one way of doing. There are definitely smarter way, but I just want to show you step by step how you can achieve that. So basically, I'm selecting my source, I have selected my target. I need to define the element class, so it's a plain interface, and a material. So I'm going to start with no tension interface, and I go for a cool friction. Click OK, and over there I'm going to specify some value for the three stiffness component. So 1E8 for the normal, and for the shear 5E6 in both directions. And for the Coulomb friction, we are going to specify a cohesion of 250, friction angle of 40 degrees, a dilatancy angle of 2. And we go for a gapping model, as I explained in introduction. And with a tensile stress of 10 kilonewton per square meter. I click OK. One more thing we need to specify is basically the local element axis. So we need to create a geometry set. So interface geometry, and we will use also this face for this set for the other set of interface. And over there we define that the local element axis is in the y direction. And finally you click create. And you see that something is happening there. You see some symbol which represent basically your one side of your interface. And if you go under the geometry tree, under connections, under interface, you will find your dam foundation interface. So if I bring back my foundation, you see in red the other side. So the red is the source and blue is the target. It gives you the orientation of your interface. So now that we have defined the dam foundation interface, we still have the cantilever interface. So basically the interface between every dam segment to define. And again, we are going to use the same strategy. So we need first to select the side face of the dam segment, which is the source, and the other one, which is the target. To make things easier, we are going to use an exploded view of the dam. So I'm going to hide the foundation. I'm going to geometry, modified, open the virtual transformation. I'm going to select the dam, and over there, I'm going to make an explode view with a factor 333. I click apply, and now I activate this view. So it will be easier for me to select the side. I'm also going to hide the dam foundation interface. And now I can basically rotate and easily select the different side of the model. So let's assume that if we look at the dam from the upstream, like we do now, the left faces of the cantilever are used as a source, while the right face are as a target. So basically, I'm going to open the connection box and define a new set, the segment interface. And basically for the source, I'm going to select the left side of the segment. I rotate it like that, and I start selecting the different face. So this is a little bit let's say the tedious part. You just need to be a little bit focused in the selection to make sure that you don't forget any of the face, but again, nothing that you can achieve within a couple of clicks. So this is one side, and now we need to do basically the other side. So I just rotate, and I repeat this exercise for the target. Just make sure that you don't click. So when selecting, also keep an eye on what's happening in your target box. And you can always rotate your model to make your selection easier. So the selection is done. For the element class, again, we go for the structural plane interface. And we are going to define the material, and we are going to define the not routed interface. So it's interface element for the class, linear elasticity. And over there, we define again some stiffness, so 2.5 E8 for the normal, and 6,000 kilonewton for the shear. And we can use the interface geometry, and we click create. And you see that now it's even more apparent, especially in this exploded view, that in blue you have the source, and in red the target. So it gives you the orientation. So I can now close this exploded view. I can hide and bring back my geometry foundation. So we have defined basically all our interface. The last thing I want to add is the growth interface, because I have defined a material for the not growth interface, but in my phase analysis in the phase 3, I want to basically switch to a growth material. So I'm going to duplicate this material. I rename it to growth, and I'm going to edit it. And over there, I'm going to increase the shear stiffness. And you will see how we can basically update the material between two phases in the analysis setup. So now my material is complete. I'm going to assign the boundary conditions, the load, and then we will move on with meshing. So in terms of boundary condition, basically we are going to support the different edges on the bottom of our foundation. So I'm going to define the first set, which is the X direction constraint, which will be part of a general support set. It's going to be face. So I select this one and this one. So these two vertical faces, which are constrained in the X direction. I click create. Then I'm going to repeat the same operation for the Y direction. But now I select front and back, and I constrain the Y direction. Click create. Finally, I'm going to constrain the bottom in the Z direction. So I'm going to call it Z direction. And I select this one, and I check this one, and I click create. So now all the side of my model have the proper constraint. Last part before we move to the mesh is basically to define the load. And the first one we want to consider is a global load. It's the dead weight. So we go to the global load section, and we create a set self-weight. I'm going to give the same name here. And this applies to the entire geometry, so you don't need to specify to which part of the geometry it appears. It will result under your geometry tree with a load case, which is a self-weight. And here, one of the interesting part of this modeling is how to define basically the hydrostatic pressure on the upstream phase, which is basically due to the reservoir. And you will see why it was important to have defined this imprint of the reservoir level. So we go to the load selection here, and we create a set reservoir water. I'm going to give the same name to the load case. The load target type is a phase, and the load type is hydrostatic pressure that we select here. And basically, I need to select all the upstream phase of the dam, which are below this line, which is the top level of the water, and also this phase. So I zoom a little bit so that I can select this one, and I click on the different phase that I want to select, and that's where the hydrostatic pressure will be applied. I still have a little piece here, and here we go. I can zoom out, and I define the hydraulic head, which is 410 meters. And I click create, and here you see the representation of the hydrostatic pressure appearing. So the geometry is now complete. The next step is basically to tell Diana how we want to mesh this model. So we move to the mesh section, and we are basically going to mesh the foundation and the dam with different dimensions. So something relatively fine for the dam, and we go for a relatively coarse mesh for the foundation. So we start with the dam, and we are going to for shape selection, and we are going to use an element size. We can already specify the element size. It will be, we go for 8 meters, and I'm going to select all the dam segment. So I remove the foundation, and I select all the dam segment, and I click apply. I bring back the foundation, I select it, and here I'm going to use something much coarser. We go for 75 meter element size. So the model is just relatively coarse, so that we don't spend too much time processing it. Then I click apply, and then I mesh. So it takes a little bit of time, but I've already prepared another window with the model. Let me get back to that. Here is my window with the model. So just to avoid that we spend too much time processing it. So this is basically the mesh foundation. I'm going to hide some of the components so that we can better see. So I'm going to hide the loads and the interface, which are also created in the mesh. So you can see the dam is much finer in terms of mesh than the foundation, and we have a progressive mesh around the connection due to the imprint of the dam into the foundation. And if I go to the mesh section, under the elements, you can see that I have all my elements. I have basically the dam and the foundation element, and I have my segmented interface, and also the dam foundation interface set, which basically connects the foundation to the dam. So, having said that, let's now move to the analysis part and the analysis setup. So we are going to define an analysis which will consist of 3 phases, and each phase will be followed by a structural node. So first I define a new analysis that I rename. I call it dam analysis. And I'm going to define a phase analysis that I'm going to recall as well, rename. And this first phase, I call it the stress initialization. Without typo. And over there, basically, only the foundation will be on, because I don't consider any dam at the beginning. And basically, there's no interface neither. So it's only the dam and the support. So my first phase is defined. Then I add a structural nonlinear. So this structural nonlinear analysis will consist on a start step to do the stress initialization. So I'm going to add a start step, and I'm going to remove the load step, which I don't need. And over there, I basically need to tell Diana what we are going to do. So I open the start step, and I mentioned that we are going to initial stress, and we are going to calculate with the self weight, and the additional load is set also to self weight. I click close. Then we define a second phase. So I can go there, add a second phase. And in this second phase, basically, we consider the dam construction. So we consider that the dam is there. So it means that basically all the element sets in terms of for the dam segment, the foundation, and also the interface between the dam and the foundation and the segment are there. So nothing to deactivate or activate there. I'm just going to rename this phase as dam construction, just to make the administration a little bit easier. Next, I'm going to copy this structural nonlinear, and I will basically adapt it based on our need. So it's again a start step. I don't need to calculate this. I just use the load from the previous phase, which is basically my dead weight, but it's coming from the previous phase. And to facilitate the convergence, here I'm going to use a second method. This is just because we had run some trial and error, and this facilitates the convergence. Then we are going to specify or define the last phase of our analysis, where basically we inject or grout the interface, and also where the hydrostatic pressure come into action, so basically operating the dam. So I add another phase, but I'm going to rename to injection of interfaces. And here I'm basically going to change the material of my segmented interface. It was by default to not grouted, and I'm going to put grouted interface for this segmented interface. But the only thing I do with the phase here, and again, I'm going to duplicate my analysis, my nonlinear analysis. So I got my structural nonlinear 2. And over there, I'm going to add my reservoir water, my hydrostatic pressure. So in my start step now, I'm going to make an additional load. So I keep using the load of previous phase, so this I keep. And here I choose reservoir water, which is by hydrostatic pressure. And then I click close. And here, basically, I have my analysis setup with 3 phases. First phase where I just consider the foundation with stress initialization, so only the foundation set is active. Then in a second phase, I consider that the dam has been constructed. So I consider also the self weight of the dam in this part. It means that also the interface for the foundation and between the foundation and the dam and the segment are active. And then in the last phase, I change the material property of the cantilever interface to grouted. So now the segments are grouted to each other. And I also operate the dam, so I apply take into account the hydrostatic pressure. So we are basically ready to run this analysis. As you can imagine, I have already run the analysis so that we can look at some of the results. You just have to find the correct window. This is the one with the analysis results over there. So you can check that everything went fine. So the analysis converged. There was no warning or error message. So it went all fine. And in the very little time that we have left, I can, for instance, show you the displacement of the dam, for instance. So I'm going to reduce that a little bit. Increase this part. So I'm going to hide the foundation. So in the mesh over there, I'm going to hide the foundation. I'm going to the phase where we have the dam constructed. And I'm going to look at the, something went wrong with there. That's the joy of the live demo. So in that case, I'm going to run my analysis. It seems that something went wrong. Too many files open at the same time, probably. Just 1 second that we get things back to life. So I want to go to the dam construction and I want to show some displacement. So if I zoom in a little bit, this is basically the y displacement of the dam segment. So basically we are in an ungrouted, we have ungrouted interface. So you can see that there is a relative displacement between the interface. And if we move to the next phase where it's grouted, you don't see that anymore, but what you see is, or what you can observe basically, is the arching effect on the top of the dam due to the hydrostatic pressure, which is now considered in this third phase, where we switch also from non-grouted to grouted interface. One of the last thing I can also show you is eventually some interface results. So I go for the last phase, and over there we can look at some interface relative traction, for instance, this one. And we can see that the top of the interface is experiencing some compression due to the hydrostatic pressure, where the bottom is in tension, and you see that the tension is mainly on the upstream side. You also have some tension at the downstream side, but less with a lower magnitude. So this is it for this live demo. So you could see that within 55 minutes we could set up, I would say, a relatively advanced model. So we imported a CAD model, a simple one, I agree, only consisting of 2 shapes, where then we did some geometry manipulation and in a way that we could create a segmented dam. So we did a lot actually in terms of geometry, because from one set we divided it into something like 20 segments using different geometry operation and different geometry tool. We created interface between the foundation and the dam, and even more challenging, between the different dam segments. But it was not really challenging. I mean, as long as you have a proper administration, it goes all fine. And thanks to this virtual transformation tool, you could easily make your face selection. We have defined an hydrostatic pressure, and then we have basically set up a complete phase analysis, including stress initialization and the construction of the dam, and then the operation of the dam. So I hope you enjoy this live demo. Let me see if there are any questions or anything. Apparently there are no questions. So before we end this live demo, just want to bring to your attention that in the coming weeks, coming days, we will have a lot of activities going on, especially in terms of online courses. So the topic is not really the upcoming course is about wind turbine foundation, so something a little bit different. It will be next week, so if you are interested, we still have a few seats available for this course. Then we will have later in April a course on masonry structure. So if you are dealing with historical building or things like that, that might be a very good training. So keep an eye on the website and for the course content, and feel free to register. And for the one who are into dam and want to know more about hybrid frequency analysis applied to dam structure, we will be having a course in the first half of May. So again, take a look at our website. There is all the information about these courses, and feel free to register. And in June, in a couple of months, we will have our regular RC course. But some of you, I recognize some them who have already attended. But for the one who never did, I mean, this is a good course to get all the basics about Diana. So I'd like to thank you all for attending this live demo, and I wish you all to have a pleasant day. Thank you very much. Bye.